1. Webb telescope captures first direct image of a young exoplanet shaping its star system. 2. JWST spots Saturn mass exoplanet TWA7b. Professor Michael Rakowski on cosmic discoveries. 3. JWST can now directly image exosaturns and exojupiters. Breakthrough in exoplanet detection. 4. James Webb Telescope captures smallest exoplanet ever seen by direct imaging. 5. Astronomers capture first direct images of hidden exoplanet using JWST. 1. Webb Telescope captures first direct image of a young exoplanet shaping its star system. The James Webb Space Telescope has made a groundbreaking discovery by capturing its first direct image of an exoplanet, a Saturn-sized world that is influencing a nearby star system. This remarkable achievement raises an intriguing question. Have we finally begun to grasp how young planets shape the stars and systems that surround them? Published on July 13, 2025, at 5:46 a.m., this finding is significant for several reasons. The exoplanet, designated TWA7b, possesses a mass comparable to that of Saturn and orbits a star that is merely 6.4 million years old. This provides scientists with a unique opportunity to observe the formative stages of planetary systems. Utilizing a specialized tool known as a coronagraph, which effectively blocks out the overwhelming brightness of the star, the Webb telescope was able to detect the faint light emitted by the exoplanet amidst the surrounding dusty disk. Notably, the gravitational influence of TWA7b appears to be actively shaping the dust rings encircling its star. This marks the first instance where a directly imaged exoplanet has been associated with the sculpting of its own stellar environment. This pivotal discovery paves the way for the identification and examination of smaller, more distant exoplanets, thereby enhancing our understanding of how planets and solar systems, akin to our own, come into existence. As Anne-Marie Lagrange, the lead researcher, stated, "Our observations reveal a strong candidate for a planet shaping the structure of the TWA7 debris disk, and its position is exactly where we expected to find a planet of this mass." Ian Todd, the content editor for BBC Sky at Night magazine, has been captivated by the wonders of the night sky since he first spotted Orion at the age of 10. This discovery not only excites astronomers, but also invites us to ponder, what other secrets do the stars hold about the formation of planetary systems? Are we on the brink of uncovering more about our cosmic neighborhood? Share your thoughts in the comments below. 2. JWST spots Saturn mass exoplanet TWA7b. Professor Michael Rakowski on cosmic discoveries. Are we truly alone in the universe? For centuries, this question was pure speculation. Now, we're building the tools to find a real answer, and the latest breakthroughs are nothing short of breathtaking. In a thrilling announcement from late June, NASA revealed that astronomers, using the unparalleled power of the James Webb Space Telescope, JWST, have likely spotted a new world. Orbiting a star known as TWA7, this potential planet appears to be a gas giant, reminiscent of our very own Saturn. If this finding is officially confirmed, it will mark the very first time the JWST, launched in 2021, has directly imaged and discovered a brand new exoplanet. So, how did the telescope pull off this incredible feat? Imagine trying to spot a tiny firefly buzzing next to a colossal, blinding searchlight. That's the challenge of finding a planet next to its star. The star's overwhelming glare usually washes everything else out. To solve this, the JWST employed a brilliant piece of technology called a coronagraph. As NASA explains, this instrument acts like a sophisticated sun shield, precisely blocking the light from the central star, allowing the faint, reflected light from the orbiting planet to become visible. It's a cosmic game of peekaboo, and we're finally able to see what's hiding. The candidate planet, designated TWA-7b, is estimated to have a mass roughly equivalent to Saturn, or about 100 times the mass of Earth. But here's the part most people miss. Simply finding the planet is just the first step. Michael Rutkowski, an associate professor at the University of Minnesota's Mankato campus, helps put this into perspective. He clarifies that an exoplanet is, quite simply, any planet found orbiting a star other than our Sun. The true excitement with the JWST, he notes, lies in its extraordinary ability to go beyond mere detection. It can actually dissect the light passing through an exoplanet's atmosphere. Are there planets out there that are the size of the Earth in mass, that have atmospheres of oxygen, or, ozone or carbon dioxide or water? Rutkowski poses. JWST can find some of those components in the atmospheres of these other planets, and that's what's really exciting. This is the part that truly electrifies scientists and the public alike. The potential to find the chemical fingerprints of life on another world. Of course, finding something like oxygen isn't an automatic confirmation of alien life, as non-biological processes can also produce it. But here's where it gets controversial. Some in the scientific community argue that while searching for these biosignatures is crucial, we should also be on the lookout for technosignatures, evidence of advanced alien technology. The debate over which is more likely to be found first is a fascinating one. And while the JWST is performing these deep, targeted investigations, another new astronomical powerhouse is preparing to change the game entirely. At the end of June, the Vera C. Rubin Observatory in Chile switched on the largest digital camera ever constructed and captured its first test images of the night sky. In a mere 10 hours of observation, it documented millions of stars and galaxies, along with an astonishing 10,000 asteroids. To grasp the sheer scale of this camera, consider this. A single image from its full field of view would cover the same area as 400 high-definition television screens arranged in a grid. The amount of information it will gather is staggering. According to Rutkowski, the data generated by this telescope over its mission lifetime will be immense. It would produce petabytes of data. That's 10 quadrillion bytes worth of data over its mission, he explains. To make the number more concrete, he offers a stunning comparison. The Rubin Observatory is projected to generate roughly double the amount of data that a platform like TikTok will produce worldwide over the same period. It's a data tsunami that will dwarf a significant portion of all the video content currently being created on Earth. We are entering a golden age of astronomy, with powerful new eyes giving us both deep, focused views and vast, comprehensive maps of the cosmos. With these incredible tools at our disposal, what do you believe we will discover first? The simple chemical traces of biology, or the unmistakable signs of an intelligent civilization? Which discovery would change our world more? We'd love to hear your thoughts in the comments. 3. JWST can now directly image exosaturns and exojupiters. Breakthrough in exoplanet detection. Imagine discovering a planet larger than Earth, but with a swirling atmosphere like Jupiter. Could this be possible? New research suggests that the James Webb Space Telescope, JWST, might soon reveal such worlds, but only under specific conditions. This breakthrough could redefine how we search for life beyond our solar system. However, here's where it gets controversial. Scientists debate whether JWST's current technology can truly capture these distant giants without distortion. The study claims that JWST has the potential to directly image exoplanets resembling Saturn and Jupiter, provided they orbit stars close enough to Earth. These gas giants, which dominate our solar system, are often hidden by their host star's brightness. But with advanced coronagraphy techniques, JWST may now filter out starlight, allowing us to glimpse their atmospheres. For example, a planet like Saturn, with its iconic rings, could appear as a faint blur against the backdrop of its parent star. And this is the part most people miss: the nearby requirement. While JWST is designed to look at distant galaxies, its ability to image exoplanets depends on their proximity. A planet orbiting a star just 100 light-years away is far easier to detect than one 1,000 light-years away. This means the discovery of exosaturns or exojupiters will likely focus on relatively close systems, not the farthest reaches of the universe. But some astronomers argue that this might not be as straightforward as it seems. Could the same technology that reveals Saturn-like planets also uncover smaller, Earth-sized worlds? Or might the data be misinterpreted, leading to false positives? What do you think? Share your thoughts in the comments below, because the future of planetary science is as much about debate as it is about discovery. For James Webb Telescope captures smallest exoplanet ever seen by direct imaging. Brace yourself, because what NASA's James Webb Space Telescope has just accomplished is absolutely stunning. It has managed to capture the smallest exoplanet ever seen through direct imaging. Yes, we're talking about the multi-billion-dollar mission that some people call the risky spend. But here's where it gets controversial. The sheer number of breakthroughs it has already produced makes many experts insist that this enormous investment has practically justified itself. When the James Webb Space Telescope started full operations in 2021, it opened up a whole new window into our universe. Its cutting-edge technology has allowed astronomers to investigate everything from the planets in our own solar system to mysterious objects lying far beyond our usual reach. One of the most thrilling areas it has revolutionized is the study of exoplanets, those planets that revolve around stars outside of our solar system. The term exoplanet might sound exotic, but all it really means is a planet that orbits any star other than our Sun. Based on this definition, astronomers have identified nearly 5,900 exoplanets to date, and that's only the tip of the cosmic iceberg. So what's the catch? Even though scientists know these planets exist, they're notoriously difficult to see directly. In fact, less than 2% of all known exoplanets have been identified by direct imaging, mostly because their faint glow is easily overshadowed by the stars they orbit. Most of these distant worlds are detected by the brief dip in a star's brightness as a planet passes in front of it, a method known as the transit technique. But now, thanks to Webb's exceptional sensitivity and resolution, a different path is opening up. We can actually see some of these exoplanets more directly, and that's a game changer. And this is the part most people miss. The exoplanet Webb captured isn't even large compared to other planets we've managed to image, yet it showed up in Webb's view clearly enough to make history. The newly imaged planet is a young gas giant, comparable in size to Saturn, which has a radius about 9 times that of Earth. This puts it soundly in the small category for directly photographed exoplanets, especially since every other exoplanet observed in such detail before has been significantly larger. Try wrapping your head around that. It's roughly 1/10 the size of the smallest exoplanet ever directly imaged before this. What's even more breathtaking is that it's located roughly 110 light-years away from us, a distance engineers and scientists once doubted we could probe in detail. Here's another reason this discovery might spark debate. Some question whether we should celebrate scientific curiosity that roams such vast distances instead of focusing resources closer to home, such as on Moon or Mars missions. Yet, astronomer Aimé Lagrange, speaking on behalf of the French CNRS and the Paris Observatory, has emphasized that Webb has only started to show us its power. Webb opens a new window, in terms of mass and the distance of a planet to the star, of exoplanets that had not been accessible to observation so far, she explains. Now, let's talk details. We still don't know exactly what this planet's atmosphere is composed of, although researchers are hopeful that more data will fill in the blanks soon. We do know it has 2 colossal rings, likely rich in dust and rocky fragments, and a third, narrower ring where the planet itself resides. The planet and its star remain young, at only about 6 million years old, which is practically a cosmic newborn. This means the planet could still be putting on mass, sweeping up material in its orbit as it continues to develop. Naturally, everyone's buzzing about how this sets the stage for finding even smaller targets in the future, maybe even Earth-sized planets. Critics might argue that we're still a long way off from photographing truly Earth-like worlds, but Lagrange remains optimistic that we'll eventually get there. If and when that day comes, the implications will be enormous for those hunting signs of extraterrestrial life outside our solar system. So here's a question for you. Does this breakthrough convince you that the James Webb Space Telescope's cost was worth it? Or do you believe we should focus on more tangible pursuits closer to home? After all, the notion of someday imaging a planet similar to Earth, complete with any potential life forms, raises all sorts of thrilling possibilities and challenging debates. Go ahead and share your thoughts. Do you find this pursuit of distant worlds a visionary leap forward, or should our gaze turn back to our own cosmic neighborhood first? 5. Astronomers capture first direct images of hidden exoplanet using JWST. Imagine peering into the vastness of space and spotting a world never seen before. That's exactly what the James Webb Space Telescope, JWST, achieved, marking a monumental leap in our quest to uncover the mysteries of the cosmos. But here's where it gets controversial. What does this mean for our understanding of the universe? Let's dive into the details of this groundbreaking discovery and explore the implications it holds for future explorations. The JWST has recently unveiled images of an exoplanet, previously hidden from our view, using advanced imaging technologies. This discovery is not just about adding another planet to our list. It represents a significant shift in how we can discover and study distant celestial bodies. Exoplanets, which orbit stars other than our Sun, provide critical insights into the formation and evolution of planetary systems, including our own. Traditionally, most exoplanets have been detected indirectly, as they are typically obscured by the bright glare of their host stars. However, the team from Observatoire de Paris PSL and University Grenoble-Alpes has pioneered a method using a coronagraph on JWST's MIRI instrument. This device effectively eclipses the star, similar to how the moon blocks the sun, allowing astronomers to observe the planets lurking nearby. Their findings, published in the prestigious journal Nature, reveal a new exoplanet nestled within a disk of debris and dust. Named TWA7b, this planet is a first for Webb in terms of direct imaging. It resides in a dynamic environment, characterized by rings and gaps within the debris disk, which suggests gravitational influences from the planet itself. These debris disks are remnants of the early processes that formed planets, consisting of gas and dust that didn't coalesce into celestial bodies. Over millions to billions of years, these disks evolve, showing structures like rings and voids that can indicate the presence of planets. TWA7, located about 34 parsecs from Earth, displays such features, which were key clues leading to the discovery of TWA7b. The breakthrough came on June 21, 2024, when Webb captured images using a filter designed to pick up mid-infrared light, revealing several bright spots. Among these, one spot corresponded with the location and characteristics expected of an exoplanet, ruling out other possibilities, like distant galaxies or solar system objects. Further analysis using the Hades model estimated the planet's temperature and mass, suggesting it was similar in size to Saturn, but much lighter. This finding was supported by simulations showing how a planet of this size could influence the surrounding debris, creating the observed ring structures. This discovery is particularly exciting because TWA7b is significantly smaller and colder than any other exoplanet directly imaged before. It shines not by reflected light, but by its own thermal emission, offering a unique opportunity to study its atmosphere and composition in detail. The success of this mission underscores the critical role of tools like Webb's coronagraph and mid-infrared capabilities. These technologies are paving the way for future discoveries of even smaller, Earth-like exoplanets. And this is the part most people miss. Each new planet found brings us closer to answering the age-old question of whether we are alone in the universe. As we continue to refine our technologies and strategies, the potential to discover new worlds that resemble our own Earth grows. What do you think the future holds for exoplanet exploration? Do you believe we are on the verge of finding worlds that could host life? Share your thoughts and join the conversation about this fascinating frontier of science.